So once I'm in class, and I will not do this for this YouTube video here, but in class, what I will do is I will perform a demonstration of how hashing works, how mining works, and how it relates to the architecture of a blockchain. Now, I've obviously not used the term hashing yet at all, but I will explain this in the classroom of how it actually works. Um, as a quick disclaimer, there is a extremely nice demonstration by Anders Braunworth, who has put this on a website, and you can also find it on YouTube under anders.com at blockchain, where he describes essentially the workflow of a blockchain. He shows digital signatures, he shows hashing, he shows blocks, he shows how blocks are linked, and he shows what it means in a distributed system. It's an excellent presentation, and you know on my slides you find it here. I recommend that you go through it. It will also be I forked it on the slides that I posted online on slides.com. So to summarize, what the demonstration will be showing you, and you've not seen this, I invite you to look at it as you move along. A block essentially is just text. That's really all that there is. There's nothing special about it. It's just a collection of text. What a hash is it is a function that produces a collection of letters and numbers, and it does that in a deterministic manner, meaning that if you have the same text, you create the same hash. Now, in the next lecture, I'm going to go into a little more details because there's specific features of hashes that make it extremely useful, but we're going to get there at a later point. Now, one of the things that is important is that it's impossible to invert. Now, you can try to guess it, but it is essentially impossible. And when I say impossible, it means it's impossible to do so with a deterministic function, or to be even more precise in a mathematical sense, we have not found a way to invert it in polynomial time. So if you want to be totally precise. Also, not here on the slides, is also a hash is always of fixed length. Now, in the demonstration, I also showed you what a nonce is. Now, a nonce is a particular piece of text so that when you combine it with the hash of the remaining information, it produces a new hash, which in this particular demonstration starts with 4 zeros. Now, that is a very crucial component that we'll need in what's referred to as the consensus protocol, which is what allows us to update information on the blockchain. Now, again, we have not gotten to that at this point, but it is something that we'll go into very great detail in the next lecture. The bottom line is, if you go back to the part where I talked about databases, we needed to have a rule which allows us to update the database, and the fact that the information, the hash of the information that is in the block has a particular structure is a coordination device. Now, finally, the blocks, no, not finally, we had 4. The blocks are linked. Again, this is something that comes out of the demonstration, which is in the last in the last video, I argued that the architecture of the block involves a header of the block has part, which is a link. That link is essentially a hash of the information in the past block, and it is part of the information that is included in the current block. The bottom line is here is if you want to change anything in the past block, you will have to change, if you change anything in the past block, you will change the hash. Therefore, you change the information of all follow-on blocks. If you were to do something like that, there would be a contradiction in the information that is available in the distributed network, and therefore such a change would be rejected, would not be accepted. And that process essentially, therefore, allows these states and these blockchains to be immutable. All right. So to summarize, what we have is in this 30,000 feet overview, we tried to obtain an understanding of how value transfers work today to motivate why we would be interested in a blockchain. I tried to give you a demo of a blockchain transfer. I described to you how blockchains work as a database. We tried to understand the workflow of blocks and the architecture of blocks and a blockchain. And then I showed you a workflow of how blocks and blockchains are being built. Now, you'll hopefully have many, many questions after I gave you this quick demo. I told you that blocks are linked by hashes. So what is a hash? Where does it come from? What does it do? Why do we do it? We have transactions are associated with addresses. You want to understand what these addresses are. I talked a lot about, verification and validation of transactions, which involves signatures and signing. So you want to understand how does the signing work. And then finally, we have block validation. So how do blocks actually get added to the blockchain, and why do we do this in this strange form where we add a nonce so that there is a particular hash? All of these items have to be clarified in due course, but for now, we've just set the stage for what is to come in the next part of this module.